Good afternoon, dear students. Today we are going to study the continuation of distillation. That is the next distillation apparatus, flash distillation. So it is defined as a process in which the entire liquid mixture is suddenly vaporized. So why the name it's called as flash distillation means it will be the liquid will be vaporizes in a fraction of seconds. That is like how the camera flashes, no, like that. So it is called as flash distillation. Means the liquid is passed in a high pressure from a region of higher vapor pressure to a region of lower vapor pressure. So the liquid suddenly flashes. The entire liquid will be converted into vapors and you are going to get the pure liquid. This is also known as equilibrium distillation because the phase separation of the liquid and vapor will take place in the equilibrium. So it is also called as equilibrium distillation and also called as flash distillation. So next is with respect to the principle. So you can see the diagram here. So here the feed mixture, there will be an inlet for the feed. It's connected to the pump. Pump is for the pump is required for forcing the liquid to move from higher pressure zone to the region of lower pressure zone. So that you are placing the pump here, you are pumping the liquid to move. So here heater is there, heater for heating the coils. The liquid will be entering in these coils and it will go to the pressure reducing valve. Here in this box chamber it will be at high pressure, it will be went to the lower pressure where there will be a separator, that is vapor separator, vapor to condenser. Next is the liquid will be collected in the flask. So here the working principle is, so the liquid is here allowed to move from higher pressure zone to the region of lower pressure zone. So the entire liquid will be suddenly vaporized. During this process, the liquid gets, the chamber gets cooled also because it's went to the lower pressure zone. So the individual molecules get condensed, which is have high boiling fraction. Means here there should be a high difference in the boiling points of liquids. That types of mixtures can be separated here. Whereas low boiling fraction remains as vapor, means the liquid which is having low boiling point that will condense into vapor, and the liquid which is having high boiling point they will remains as such. Liquid and vapor is kept in intimate contact until the equilibrium is achieved. So it is also called as equilibrium distillation. Liquid fraction is collected separately, whereas vapor is separated from the liquid and the condenser. So next is with respect to the construction. It consists of a pump which is connected to the feed reservoir. Pumps help in pumping the feed into the heating chamber that I have said to you. The other end of the pipe is directly introduced into the vapor liquid separator, that is a vapor separator. The vapor outlet is provided at the top, whereas the liquid outlet is provided at the bottom. So next is working. As I explained you, the feed will go from the feed inlet to the heater that will be pumped through the pump. The heater will give its heat to the liquid which will be flowing. So due to the high difference in the boiling point and due to the heating efficiency is more and it will be at high pressure, so the liquid in the fraction of seconds it will convert into vapors. Then it's passed to the low pressure zone. There it will be connected to the vapor separator that will separate the vapor to the condenser. It will pass, and liquid which will be left as such, that is the other solvent that will be collected there. Next is uses. It's used for separating components which boil at widely different temperature. As I said you, the liquid mixtures you are going to take now, that should have high difference in the boiling point. Widely used in the petroleum industry for refining crude oil, means for the purification of crude oil from the raw material. It is used in petroleum industry. Advantages: it is a continuous process, means you can operate this continuously. Disadvantage: not suitable for separating components of comparable volatility, means the liquid which is having nearly or almost same boiling points, that cannot be separated easily. Not suitable for two compartment system. 100% pure component cannot be obtained, means not suitable for component system, means is nothing but for two component system, means if it is having more than two solvents, that cannot be separated here. 100% pure component cannot be obtained by this flash distillation. So next is fractional distillation. So as the name itself indicates, it will be having a fractionating column in between the flask or the feed inlet and to the condenser. There will be a fractionating column. So here you can separate the miscible liquids also, and the liquids which is having closer boiling points also you can separate here. It's a process in which vaporization of liquid mixture gives rise to a mixture of constituent from which the desired one is separated in the pure form. So from the mixture of components you can separate the individual components in the pure form. So it is also called as rectification. Rectification is a separation of individual components in the pure form. This method is used to separate miscible volatile liquids whose boiling point are close. As I said you, the flash distillation, the disadvantage is you cannot remove the mixtures which is having lower boiling points. So here it is the advantage that the liquids mixtures which is having lower boiling point are same, nearly same, almost same boiling points, that can be separated easily. So you can see here in the diagram, so a fractionating column is there above the round bottom flask to the other side of the condenser. So you can see that this in detail here how it is going to work, that is given here. So the principle involves the mass transfer process involving counter current diffusion of the components at each equilibrium stage. Means from the feed inlet, here the feed inlet is there, steam inlet is there, the feed inlet is get heated by the steam, then it will move to the, then the liquid starts to form into vapor. They will go to the fractionating column. So they will come in contact with the fractionating column. There it will be again which is having the tendency to escape, that will convert into vapor and they will escape to the condenser. But in between there will be the vapor and liquid phase, means that has cooled down, means it will be coming back again to the still. That's the procedure. When liquid mixture is distilled, the partial condensation of the vapor is allowed to occur in the fractionating column. So first partial vaporization will be there, then it will move to the condenser. In column, ascending vapor from the still is allowed to come in contact with the condensing, returning to the still. So this in detail again I will explain you in the offline class how it's going to work, because here the liquid starts to boil in the feed inlet, means here it will go in between the fractionating column. By the same time the liquid which has cooled down in the fractionating column, that will be coming back again to the still, because the mixture of liquid will be there. No, that's given here in detail that you are going to study here. So it's used for the application used for the separation of miscible liquids such as acetone and water, chloroform and benzene. These are have the mixture of liquid which will be having the same or nearly same boiling points that can be separated. Disadvantage, cannot be used to separate the miscible liquids which are azeotropic mixture. So azeotropic mixture means they will be having same concentration of vapor and fluid phases. If it will be there, means the equilibrium will be attained, so that substances cannot be separated. So next is the construction. You can see the diagram here. Fractionating column is inserted in between the still and the condenser. Still is nothing but your round bottom flask or the sample where you are going to place that one. A provision is made for the supply of heat, that is the steam coil at the bottom of the column. At the top a condenser is provided. Column has large surface area for providing the sufficient flow conditions. The broken lines in the column, this one indicates the contacting devices. So next is working. You can see here working. So this is the mixture, you can see. Consider mixture of two immiscible liquids A and B containing 20 and 80% of A. So this diagram is with respect to this fractionating column, how it is going to separate, that is given here. So it is having mixture of A and B solvent. A is 20%, B is 80%, means in a 100 ml the A is having 20 ml and B is having 80 ml. So now they have given with respect to this diagram, liquid A, more volatile component, is having lower boiling point than B, that is less volatile component. These liquids do not produce constant boiling point mixtures. When the boiling point of the mixture is reached, the vapor composition curves are drawn by showing the lowest pair of the curves. So you can see first one, liquid containing 20% of A, initial vaporization from the distillation flask. You can see here. So first, initially the liquid A starts to condense into the vapors. So this will move after again giving steam. It will move to the next fractionating line in the column. So here first condensation and partial revaporization. So here the liquid will first condenses, again it will goes to the vaporization. So vapor containing 60% of A formed only from liquid containing 20% A. So in the after first step, only in the first condensation, so from the liquid 20% of A, 60% is getting condensed, means from the, here they are telling means 20 ml 60% of the vapors are formed. So next is second condensation and partial revaporization. Here from the 20 ml 90% of the liquids are converted into vapor. In the third condensation and partial revaporization, from the 20 ml 98% of the solvent is converted into vapors. So last is the vapor of pure A formed from the liquid containing 98% of A, that will go to the condenser, and from the condenser it will be collected in the receiver. So in the receiver you are going to get complete 100% of A. That is the working of the fractional distillation column. So next is the distillation under reduced pressure. It may be stated as a distillation process in which the liquid is distilled at a temperature lower than at its boiling point, because how the liquid is going to be boiled below its boiling point means you are going to apply the vacuum. So only it is distillation under reduced pressure. Reduced pressure is the negative pressure, that is vacuum. You are going to give the vacuum. So you can see here the construction, the equipment, it will be connected to the vacuum pump. So here it will be having the two openings in the same flask. So one is for the thermometer, the other one is for the, it is called as Claisen flask also. So that I will explain while I will explain the construction. So principle, liquid boils when the vapor pressure is equal to atmospheric pressure, as I said same. So the external pressure is reduced by applying vacuum. The boiling point of the liquid decreases. The liquid boils at lower temperature. So due to the application of the vacuum, the liquid starts to boil below its vapor pressure. So next is the construction. So construction, it consists of a double neck distillation flask, also called as Claisen flask. It will be thick walled glass apparatus with interchangeable standard glass joints are used for vacuum distillation. In the one neck, thermometer will be placed. In the second neck, prevents splashing of the violently agitated liquid, because you are going to apply the vacuum, no, so it has to be agitated continuously, and bumping will be avoided due to the application of the vacuum. Placing a fine capillary tube in the second neck prevent bumping. Capillary tube is dipped in the boiling liquid. You can see here in the boiling liquid the capillary tube is dipped inside, but the thermometer is above only. The Claisen flask is connected to a receiver through the condenser. Vacuum is attached to the adapter to the receiver. You can see here, and with the receiver, above the receiver the adapter will be there, no, there vacuum inlet will be connected. So next is the procedure. The liquid to be distilled is filled one of to 2/3 of the volume in the flask. The flask should not be completely filled. It should be filled off or 2/3 of it. Small pieces of porcelain should be added to avoid bumping. The required vacuum is applied to the contents are heated gradually, means the liquid starts to boil below its boiling point only, then they are converted into vapors, then it will goes to the condenser, it will be collected in the receiver. So next is the large scale apparatus using vacuum still for the distillation under the reduced pressure. So the equipment remains and the working is same, but here with the respect to industry it will be the apparatus will be changed like this. So it will be having a streamlet from here, exhaust from here, the flask will be changed like this. It will be fitted to thermometer to note down the internal temperature. A slight glass opening will be given to see internal what the inside process is happening. It will be connected to the here condenser. The condenser will be like this. So water inlet from this side and outlet from this side for the condenser, that is a pump to pump here. Then it will be connected to the vacuum receiver one side. So these two are the twin vacuum receiver that will convert the liquid into vapors at the faster rate. So with respect to the industrial scale also I have given how it will be working, construction, application and all. So next is the application, preventing degradation of the active constituent, because the liquid starts to boil below its boiling point only, so it will be the degradation of the active constituent will be prevented. Changing the physical form, in the preparation of cascara sargada tablets, granular extract is suitable. So you are going to change the liquid state to completely dry state. Drying at atmospheric pressure yields a dense compact residue which is not desirable, so you should not require that one. By this method you are going to get the porous material. Under reduced pressure it produces a light porous mass which can readily be passed through the sieve to form a granular powder. So the physical form also you can get changed, that is you can get in the porous solid mass also. Disadvantage is foaming occurs, so because you cannot break the foam here. Not suitable for preparation of semi-solid or solid extracts. Complete solid or semi-solid extracts you cannot prepare, that is the disadvantage.